Welcome back, mathematicians. In this video, let's do more examples where we are testing for symmetry. So we have an equation, y equals the fifth root of x, and let's start with testing for symmetry with respect to the x-axis. So to test for symmetry with respect to the x-axis with an equation, we are going to replace y with the opposite of y and keep everything else the same. And so in this case, we have the opposite of y is equal to the fifth root of x. Our goal is to try and simplify this equation back to the original. Well, on the left side, I have the opposite of y, nothing else, so I'm just going to rewrite that without the parentheses. And as you can see, there's nothing I can do on the left side or the right side in order to get back to the original equation, and so therefore this test fails. So the graph of this equation is not symmetric with respect to the x-axis. Now let's move on to testing for symmetry with respect to the y-axis. So for the y-axis, I'm going to replace x with the opposite of x and simplify. So that'll be y equals the fifth root of negative x. Now we can simplify the fifth root of negative x because what we know is that y is equal to, and we can break up this radical into the fifth root of negative 1 and the fifth root of x. And we know that the fifth root of negative 1 is negative 1 times the fifth root of x. And so now negative 1 times the fifth root of x, we can just rewrite that as negative fifth root of x. Well, again, similarly to what we saw with the x-axis, there's nothing I can do to the left side or the right side in order to get back to the original equation. Therefore, the test fails, and the graph of this equation is not symmetric with respect to the y-axis. Now let's go to our last test, which is symmetry with respect to the origin. So for the origin, you're going to replace y and x with negative y and negative x. So this becomes negative y is equal to the fifth root of negative x. Well, as we saw with the last two tests, on the left side, there's nothing I can do, so I'm just going to rewrite it as negative y. And on the right side, as we saw with the test for symmetry with respect to the y-axis, this is equal to negative fifth root of x. What I notice is that I have a common factor of negative 1 on both sides, and so what I can do is divide both sides by that common factor of negative 1, which gives me an equation of y equals the positive fifth root of x. And so what we see is that this is the same as the original equation, so therefore it passes this test. So the graph of this equation is symmetric with respect to the origin, but not symmetric with respect to the x-axis, and not symmetric with respect to the y-axis. Now let's look at the graph of the equation, and as we can see, the x-axis is not a line of symmetry, which means that the graph is not symmetric with respect to the x-axis. Likewise, the y-axis is not a line of symmetry, so therefore the graph is not symmetric with respect to the y-axis. However, we can see corresponding points of 2, 1.149, which is the fifth root of 2, and negative 2, negative 1.149, which is approximately the fifth root of negative 2. And so, as we know, based on symmetry with respect to the origin, a graph is symmetric with respect to the origin if for every point x, y, there is a corresponding point which is the opposite of x and the opposite of y. And these 2 points are examples of that relationship, and this happens to be true for every point on the graph. All right, guys, good luck.